So in this video, we'll talk about notch filter. Similarly, we have three categories of drawing the filter lah. Okay, drawing the bandpass. I mean notch filter. Okay, so notch filter. Just now we talk about is bandpass. Now we talk about notch filter. Notch filter you're gonna connect in terms of parallel, right? Just to recap to you, these are all the things, right? Bandpass, series, notch filter, parallel. So you just need to memorize this. I also don't know how to draw. I also don't know what's the reason of drawing this. As you can see, it's only using it's a RC parallel band notch filter, right? As you can see, it's only capacitor and resistors. Do you see any inductor? No, right? So this is the thing. Okay, you have to be very careful about it. So this you just memorize lah. Okay, just know how to draw. That's all. This is the first RC the first notch filter drawing. Second notch filter drawing is a little different. How is it different? Okay, is that actually not different. Okay, hold on a while. Okay, the difference is this: the inductor and the capacitor are connected in series, and then they are parallel to the R load. Okay, so difference from this is that the capacitor, inductor, and resistors are connected in series, in parallel. So they are each individually connected in parallel. However, in this case, they are connected in series first, and then they parallel with the R load. Okay, so allow me to explain what the hell is this. Okay, remember the XC equals to XL formula, right? This one. If you were to do it out, because since they are in series, right? So you're actually implementing you're actually in doing this formula over here, right? Because they are connected in series. Although, because they are, after which they are connected in R load with series also. But nonetheless, if it's just pure capacitor and inductor connected in series, you can use this formula. So using this formula, you can know that this whole shit becomes 0 ohm, right? So you know that not 0 ohm, yeah, 0 ohm, sorry. So if it's 0 ohm, what would it be, right? V equals to IR, right? So if this dude over here it's 0 ohm, parallel to this, the R load will also be 0, right? Will also be 0 ohm. Also nonetheless 0 voltage, right? Because they are parallel. If you remember the Weber divider rule. So in this case, this is why at the same frequency, this is the frequency where XC equals to XL. Okay, this is the frequency where XC equals to XL, and therefore you can see that they actually down and then 0. And then as the frequency varies again, okay, as the frequency increases, you're gonna have a little variations okay. The frequency starts to increase in this manner, your inductors is gonna increase, right? The inductance reactance are gonna increase 2 pi FL, right? So the summation, I mean the parallel circuit of this reactance will eventually increase, right? The reactance itself will increase to certain higher ohms, right? So V equals to IZ, if you remember this is the impedance. So if you were to do that, this is where you have this point over here. And then as you slowly increase, your capacitor actually so-called bring this inductor down. So it's a little tricky here and there. So I think you can just ignore what I said earlier. Okay, fine. Anyway, just remember when XC is equals to XL, this is the place where they actually, becomes 0, the voltage becomes 0. And then for this case, the third configuration, you are connecting your capacitor and your inductor parallel, and then you connect this whole shit to the R load in series, right? So this one is a little different, okay? So it's like so previously was parallel series, right? So previously was parallel series, and then in this case was series, and then you parallel with the R loop. This is series, and then you parallel with the R loop, right? So previously was in the bandpass is parallel first, and then you use this parallel to connect with the R loop in series, right? The R loop is in somewhat. Fuck. Okay, they are connected in parallel also. Okay, parallel. Damn, my fault. Okay. So in this case, in the third case for notch, it is parallel and then series. Right. So for the bandpass wise, it is series and then series again. So you can see the trend, right? So for the bandpass, right, is parallel and then you connect with the R loop parallel again. And then another configuration is series, and then you connect with the R loop with series again. For notch, you connect with series, and then you connect parallel, and then you can also connect parallel first, and then you connect series. So this is the key thing you're gonna take note. So hold on. In other words, it's this one. So for bandpass, which is this dude over here, you're gonna connect inductor and capacitor parallel, and then you connect with the R loop parallel. And then for inductor, and then for the another configuration, you can either way, in alternatively, you can connect inductor and capacitor series, and then you connect with the R loop in series also, right? In series also. So nonetheless, for the notch filter, you're gonna connect either way inductor and capacitor in series first, which is this dude over here. Maybe I should clear a little. It's a little messy. So you connect with series first, and then you connect with the R loop with parallel. And then alternatively, you can connect the capacitor inductor parallel, and then you connect with in series with the R loop. So this is the very key concepts that I wanna convey for this. So are we done yet? Hold on. To take a look, we only clear away all these things only in the notch bandpass 3 types, and we have actually a little bit more, you know. So these are the things that are a little bit not clear lah. Okay. Which is the transfer function. Yeah, you're gonna, I don't know what the fuck is that. This is the cutoff frequency. Okay, so far so good. And then he's gonna use the cutoff frequency and do something lah. I don't know what the hell lah. Right. And then this is the phase. You can calculate the phase using this one. Okay, I think it's using frequency of the input frequency divided by the capacitor frequency, and then you can get your phase angle. Yeah, I don't know. You go and check it out lah. I'm a bit tired. So in next week also, or maybe near the test, I'll redo again for this one. So you just take note of this one first. And then what other stuffs? Yeah, and then I don't know what the fuck is that. So I'll see you in the next video. I think in the next series lah. I mean next video, okay, never mind, next series. Next video on so basically we have cleared all this except certain parts that I showed you earlier in the lecture 7 that I have unclear of. And in the next series you can actually talk about we're gonna talk about op-amp. Op-amp is a little more hairier, so hopefully I can explain it well. So I'll see you there in the op-amp videos, and then yeah, so see you, bye bye.